up to Nernst equation. And on Nernst equation, basically, uh, there was a relation that was delta G naught is equal to minus NF E naught cell. We did a question on this. Now, I'm going to give you a question that is purely based upon the Nernst equation. So just wait a minute. Where it is? Here it is. This is your question, which is based upon Nernst equation. So please do it and let me know if you are not able to solve it. Any answer? Any answer from any one of you? Seth, Alan, Farhat, Mamuna, Hiba. Okay, let me explain it. So as you can see, E naught cell is given. First of all, what is the formula for E cell? That is your Nernst equation. E cell is equal to E naught cell minus 0.059 upon N log product upon reactant. And basically this product upon reactant is Q or K. Q is your reaction quotient and K is your equilibrium constant. And in question you can see this is your equilibrium constant. So E cell will be equal to E naught cell minus, just wait a minute. C. Very good, sir. E naught cell, and we can write 0.059 upon N log of product upon reactant can be replaced with the value of K. And now you can easily solve it. E cell is equal to E naught cell has a value 0.59 minus 0.059. N is the number of electron transferred. So you can see in the question it is given that it is 1 electron. So 1 electron can be written as 1 log K. Log K, we need to calculate the value of K. K is this. So now you just need to solve it 0.0 and E cell. As you can see, it is at equilibrium. So at equilibrium, E cell, value of E cell is 0. How we know that? We know from this formula delta G is equal to minus NF E cell. N has a value 1, F has a value 96,500. And at equilibrium, you know that value of delta G is 0. So the value of E cell will be 0 at equilibrium. So I'm going to put 0 here and then again 0.59 minus 0.059 upon 1. And you can write log K. And accordingly, you can shift it to the right hand side and you will get your answer. Accordingly, you can just shift it to right hand side. So it will be 0.059. K is equal to 0.59, right? And you can also do this. Basically, this is your log K. So log K will be equal to 0.59 upon 0.059. And after solving it, you will find a value of 10. This will be cancelled by 10 times. So here it will be log K is equal to 10. And you just need to take the antilog and then the value of K will be whatever is the value, it will come to the power. So the answer is 10 raised to the power 10. That can be written as 1 into 10 raised to the power 10. So this will be your answer. Let me know if you are done with this. Very good, Saif. Alan, no answer from you. Everyone done with this? Saifullah, Alan, Farhat, Aksha, Mamuna.
Done, sir.
Okay. Now the next question, next topic we are going to start is electrochemical series. Electrochemical series. We also call it ECS, electrochemical series. So this series I'm gonna write according to this series and the value of this. You can usually decide which one is more reducing agent and which one is more or less oxidizing agent. So it gives you basically an idea that you can easily compare the oxidizing or reducing power. Here I'm going to write the lithium, and then comes your potassium, barium, and there are some metals again, sodium and then chromium, and then come your this element that is I'm writing iron. It is just it is below chromium, and there will be elements between this. So after this you will find that iron, lead, and then there is hydrogen. The hydrogen is also below this, not just below this, there will be elements below this, and you can see after this copper, iodine, Ag. If you look in the NCRT, you will see the value. And at last, fluorine. One thing is important, that this lithium is on the top, and the value of this basically this is in increasing order of E naught R value. That means a standard electrode potential. So this is the most negative value. This is most negative value, and fluorine, which is this is your most positive, most positive. So this is your most negative, this is your most positive, and this hydrogen, basically the value of this electrode potential of different elements calculated with reference to hydrogen. And here the value of E naught R for hydrogen is 0. All the value calculated with reference to this hydrogen, and here E naught R of hydrogen is 0. Always remember that the one with the highest value of negative, or you can say that the one with lowest value of E naught R. You know that if some if I'm going to ask you -10, -20, and -30, which one will be the lowest one? A smaller value, a smaller number. 30, -30, right? Yes or no?
Yes, sir.
And if I'll ask you, which one will, which one of them out of three is the most negative? That is also 30. So this is the most reducing power. This has the most reducing power, and you can say it is the most reducing agent, and the one with the highest value, or the highest value of E naught R, that is your most oxidizing power, most oxidizing agent. So if anyone will give you the value of E naught R of any substance or any element, you can easily decide which one will have the most oxidizing power, or you can say which one will have the most oxidizing, which one is most oxidizing agent. Let's say I'm going to give you my X is equal to -1 volt, Y is equal to -2 volt, and Z is equal to -3 volt. If I will ask you which one of the following is the most oxidizing power, which one of the following is the most oxidizing agent, so the one with the greater value of E naught R, and out of these three, this has the greater value of E naught R because it is -1. So this will be the most oxidized. This will have the most oxidizing power. Is that clear, everyone? Is that clear?
Yes, sir.
Okay, so please do write it and let me know. Very important topic this is. Let me know when you are done with this. Everyone done with this? Saf, Alan, Eba, please do this question. Very good, Saifullah. So as you can see, a standard electrode potential for three metals X, Y, and Z are minus 1.2 volt, plus 0.5 volt, and 3 volt respectively. Reducing power. Always remember that E naught R is directly proportional to oxidizing power and inversely proportional to reducing power. Because as you have seen that the value of E naught R increases, oxidizing power increases and reducing power decreases. So we need to do this in decreasing order of reducing power. So the one with the lowest value will be the most reducing power. So Z is the lowest value, then comes your X, and then comes your Y. So the answer will be C. Is that clear? Very good.
Yes, sir.
So you can easily solve this question, which is very important. Just wait a minute. Very good. Can I change the slide? Okay. The next topic, that is your electrolytic cell. electrolytic cell. So there is a container. You can see this is your container in which two electrode is there of two electrode is there. This is your another electrode. And this is connected with the positive terminal of the battery, and this is connected with the negative terminal of the battery. And this is your anode, and this is your cathode. And the electrode is inert here. The electrode is inert here. Now, what I'm going to do, I'm just going to dip a molten state of NaCl, molten NaCl, molten NaCl. That means I'm going to write here molten NaCl, sodium chloride. So this sodium chloride will be dissociated into ions, and anode is positively charged, so it will have positive charge, and cathode is negatively charged, so it will have negative charge. Now what will happen, the nature of charges, this positive will go to negative and this negative will go to positive. And if you remember in class 12th you have studied at anode oxidation will take place, and at cathode reduction will take place. So basically in this we need to know what is the product at anode and what is the product at cathode. So I'm going to write at cathode. So at cathode you can see which one will go. Cathode is negatively charged, negatively charged. So positive cation will go, and Na plus easily will go to the cathode and gains one electron and reduce itself into Na solid. So and at anode you can see at anode Cl minus will go and it will lose electron. It will lose electron. So in order to balance it, I'm going to multiply it by half. So you can easily write the product of this. And what is the product? You can see sodium is deposited at cathode. Sodium is deposited at cathode. And Cl2 is evolved at anode. At anode. So this will be the basically product of electrolysis here. Please do write it. Let me know when you are done with this. Are you done with this? Saif?
Yes, sir. Done.
Okay. So the previous one was the case for molten state. That means the amount of solvent or water is very low. Now we are going for aqueous NaCl. This is case 2. Aqueous NaCl. That means you have enough amount of water. So if you have this container, you can see if you have this container and there is again 2 electrode, and this is your positively charged terminal and this is your negatively charged terminal, again anode, and this is your cathode. But the difference here is Na plus Cl minus. This is your, but since it is in aqueous, so there will be ions of H plus and OH minus because it is in aqueous state. That means enough amount of water is there. Now there are two options for cathode and anode. There are two options and only one of them, Na plus can also go and H plus can also go. And now which one of this will go? And at anode you can see Cl minus can also go and OH minus can also go. But which one of them will go? That will be decided by, you can see, case 1, case A I am taking for cation. So in case of cation, that ion will migrate first. That ion will migrate first. Which has greater E naught R. Which has greater E naught R. So there is two system that there is two cation, Na plus and H plus. So you know that Na plus is in negative because here in ECS series, if you look in the NCRT, I started from lithium and you can see negative will decrease, decrease, and here it will be the value of E naught R will be 0 and then positive started. So sodium is here, which is in negative, and hydrogen is 0. So here the value of hydrogen is more. The value of E naught R of hydrogen is more. So at cathode, hydrogen will migrate to the cathode and it will reduce itself into this half H2 gas. Now in case, and sodium will be in Na plus cation in the solution. Now in case 2, it is on the basis of for ions. You can see for ions, tendency to migrate. I'm going to write a series, tendency to migrate will be, the lowest tendency will be SO4 minus 2, then comes your NO3 minus, then comes your OH minus, then comes your Cl minus, then comes your Br minus, then comes your I minus. Now you have two options, that is your Cl minus and OH minus. Now you can see easily that in Cl minus and OH minus, Cl minus wants to migrate first and it will migrate first. So at anode, Cl minus will go and lose electron and it will convert itself into half Cl2 gas and one electron will be lost. So the product of electrolysis will be hydrogen gas evolved at cathode and Cl2 gas evolved at anode. So electrolyte will be given and it has it can be asked what will be the product of electrolysis. It's very easy. Please do write it. Now in the solution we have Na plus and OH minus that is left. So what will happen after that I will explain. First do write it and let me know. Are you done with this?
1 minute, sir.
Everyone done with this?
1 minute, sir.
Okay.
Done, sir.
Very good. Now see in the solution you can see this Cl minus is converted into Cl2 and H plus is converted into H2 and it is evolved. Now in the solution in the container you have Na plus and OH minus. Na plus and OH minus. Now what will happen? This will combine to form NaOH which is alkaline which is basic. That means initially whatever is the value of pH in the solution, now the pH value will increase because the solution becomes as basic. The solution becomes basic. So this is very important. They can ask you about the pH of the solution. So it will be initially the pH of the solution is 7 neutral because NaCl and water is there. Water is also neutral almost and NaCl is neutral. But after doing the electrolysis, Cl minus converted itself into Cl2 at anode and H plus converted itself into H2 at cathode. And in the solution, we have only Na plus and OH minus, which will combine to form NaOH, sodium hydroxide, which is alkaline in nature or basic in nature, and hence the pH increases in the of the solution. Okay, can I change the slide? Please do respond.
Yes, sir.
Okay. Now, the next topic is your Faraday's law of electrolysis. Faraday's law of electrolysis. Now, what is this Faraday's law of electrolysis? As you can see, there are two laws of Faraday's of electrolysis. The first one is first law of Faraday. First law of Faraday. Now, what does it say? It says that, as you have seen that in the this system, you know that you have two electrode, anode, and then this is your cathode. And you have seen that the gas is evolved, either the gas is evolved or either the metal or the mass is deposited to a specific a specific electrode, as you have seen in the in case of molten NaCl. If you remember molten NaCl, I wrote here that sodium is deposited at cathode. So depending upon the product, whether it is evolved, if it is in gaseous state, it will evolve, and whether it is in uh, solid state, it will be deposited at a particular electrode. So this deposition or evolution of gas at particular electrode. So since they are gas or solid, it will have some mass. So this mass will be directly proportional to the charge that will pass through this electrode. Basically, whatever is the charge that you are passing through this electrode, that will be directly proportional to the mass deposited or mass evolve. Are you getting my point? Saf, Alan?
Yes, sir.
Okay. Now to remove this proportionality sign, I can easily write Z into Q. What is this Z? Z is the constant which is electrochemical equivalent. Electrochemical equivalence. This is your Z, electrochemical equivalence. Now, as you already know, I is equal to Q by T. That is a basic definition of the current, and from that definition, you have got this formula. So Q can be equal to I into T. So I can modify this formula. That is your M is equal to Z I T. M is equal to Z I T. This will be the formula. Now, what is this Z? As I told you, Z is electrochemical equivalence, but what it is basically Z is equal to equivalent weight upon Faraday's constant. This is what electrochemical equivalence is. You already know that this E is equivalent mass. Equivalent mass. And in solution chapter or in class 11th redox reaction, equivalent mass or equivalent weight you have studied, and that is basically molar mass upon X or N factor you can write. And in this chapter, N factor, that means basically number of electron gained or lost, number of electron. Basically, you can say this in case of Nernst equation, what was N? That was number of electron gained or lost. So that is the same number of electron either gained or lost. Both are equal. So you can calculate it. You can easily get it from the equation gained or lost. And F, that is your Faraday's constant. F is Faraday's constant, and I already told you the value of Faraday's constant, that is your 96,500 Coulomb. Is that clear? So we can also again modify this formula. M is equal to E by F into I into T. And again we can modify this formula. Since we know the value of E, that is equivalent weight, so mass will be equal to equivalent weight is molar mass. Capital M is representing molar mass upon N. N is the N factor, that is number of electron gained or lost, and F is Faraday's constant, and I into T. So basically this all formula is very easy if you know the basic formula. M is equal to ZQ. Z is E by F. Q is equal to IT. So you can write ZIT. And at the place of Z, you can put this E by F, IT, E, that is equivalent weight molar mass upon N. In this way, you can easily do this. Let me know when you are done with this. Are you done with this?
Done, sir.
Very good. Now I'm gonna give you a question.
Sir, what does small m represents?
That is mass deposited. Basically, if you are going to pass current or do the electrolysis, mass deposition of anything or evolution of mass of the gas. Okay,
Yes, sir.
got it? The mass of copper deposited when 5 ampere current is used for 1 hour to electrolyte CuSO4. CuSO4, that means Cu plus 2. Here, atomic weight is given of copper. We need to calculate the mass deposition of copper, and the value of Faraday is also given, 96,500 coulomb. Please do it. Hmm? Saif, if you are not able to solve it, any one of you, just let me know. Eva 1.5 gram, wrong answer. Is this Seth? I think you have. Yeah, it's also wrong answer. Okay, let's say. First of all, we need to calculate the mass deposition. So we also need to know how many number of electrons are there because it will be in need if you are going to apply the formula. So copper is there. So Cu plus copper will be in the form of Cu plus 2. And since copper is deposited, so it will gain 2 electron from cathode and it will convert itself into copper solid. Like I took the example of sodium. Yes or no? Saif, Alan, Hiba,
Yes, sir.
Hanifa. Now see, if you are going to apply the formula ZIT, you can see I is given, T is also given, but Z is not given. So I'm gonna break it into another form. EF into I into T. You can see I, T, F. F is given, but E is not given. So I'm just gonna break this also. Molar mass upon N. N is the number of electron transferred into F upon into I into T. Now molar mass is given. That is your this is your atom. So atomic mass 63.5 upon number of electron. You can see how many electrons it gained. 2 into Faraday's 96,500 coulomb into I. I is the current, that is 5, and time is in hours. So you need to convert this into second. So if you are now going to solve it, you will be getting 5.9 gram, I think. So just calculate it. This will be almost equal to, just wait a minute, 2020 will be cancelled, and here you will get 11430 divided by this is your 2 into 965, that is equal to 1930. Again 1010 will be cancelled, 1143 divided by 193, that is equal to 5.9 gram unit. Is that clear, everyone?
Yes, sir.
Okay, please do write it and then let me know. So in this way you are going to solve the question. Are you done with this? There is alternative method to solve this. Let me know if you are done with this. Saif, are you done with this?
Done, sir.
Very good. Now there is alternative method. Before that, do you know how this value 1 Faraday is equal to 96,500 coulomb comes? Basically, this coulomb that shows it is the value of charge, right? Charge.
Yes, sir.
So how the value 1 Faraday is equal to 96,500 coulomb? What does this mean? Basically, this is the value of charge on 1 mole electron. This is the value of charge of 1 mole electron. You know that charge on 1 electron is 1.6 into 10 raised to the power minus 19 coulomb. But if you are going to calculate the charge on 1 mole electron, that will be equal to, you know that 1 mole that represents Na value. Na is 6.02 into 10 raised to the power 23 electrons, this much electron. So for 1 electron, this much charge. So for this much electron, you just need to multiply it. If you are going to multiply it, you will approximately get the value 96,487 coulomb. And for in numerical, we use 96,500 coulomb. So basically this 1 Faraday, is equal to charge on 1 mole electron. Charge on 1 mole electron. Are you getting my point?
Yes, sir.
So please do write it. Let me know when you are done with this.
Done, sir.
Very good. Now see, if you are going to apply the same, basically that question can be solved with another method, alternative method for this copper. As I wrote an equation that is Cu plus 2 against 2 electron, that will give you Cu, that is in solid. Now this equation is balanced. So you can easily write in terms of stoichiometry 1 mole of Cu plus 2 react with 2 mole electron, and that will give you 1 mole of copper that will be deposited. Can I write it? That all depends upon the stoichiometric coefficient. Why it is 1 mole? Because it is 1 here stoichiometric coefficient, and this is also 1. Are you getting my point? And this is your 2. Yes or no?
Yes, sir.
But this does not bother you. It will not be helpful. We need to concentrate here. As I told you, charge on 1 mole electron, that means 1 mole electron has a charge that is 96,500 coulomb, that is 1 Faraday. So 2 mole electron can be written as 2 Faraday coulomb, and it is giving you 1 mole copper. And you know that 1 mole is equal to its atomic mass or molecular mass. That means that will deposit 63.5 gram copper. Yes or no? Please do let me know.
Yes, sir.
Now, you can easily, if you don't remember the formula, you can easily apply a unitary method and then you can solve it. Now, 2 Faraday's Coulomb deposit 63.5 gram. So 1 Coulomb will deposit 63.5 upon 2 into F. F is 96,500. Now, it is given in the question that I is 5 ampere and time is 1 hour, that is 60 into 60 this much second. So you can easily calculate the current. Q is equal to I into T. So basically we need to calculate the mass deposition if you are flowing a charge of this much. So we need to calculate the mass deposition of copper with this flow of charge. So this much coulomb will be 63.5 upon 2 into 96,500 into 5 into 60 into 60, this much gram. If you look in your notes, it is the same equation as we applied the formula and got the answer. So the answer here will be again 5.9 gram. If you don't remember the formula, only know the concept, you can easily apply the this unitary method and you will get your answer. So this is your alternative method. Let me know if you are done with this. Let me know when you are done with this. Everyone done with this?
Done, sir.
Very. Now do this question, please. Oh, very good, Hanifa. Any answer from Saif? B is not the right answer. Should I explain? Saif?
1 minute, sir.
Oh, very good, Saif. So the answer is your D. I'm going to explain it. As you can see, the number of Faradays we need to calculate required to produce 20 gram of calcium from molten CaCl2. So as you know that Ca will be converted into Ca plus 2, and it will gain 2 electron to convert itself into Ca solid. Now, as you can see that this is your 2 mole electron, that means 2F, that will give you 1 mole calcium, that means 40 gram deposition. 40 gram deposition will give at 2F, but we need to calculate Faradays for 20 gram. You just need to do this. 40 gram calcium will be deposited for 2 Faraday. So 1 gram calcium deposited that will be equal to 2F upon 40. Yes or no? Now you just need to do for 20 gram. So for 20 gram, it is equal to 2F upon 40 into 20. Now 2020 will be cancelled. 2 2 is 4 and 2 2 will be cancelled. So the answer is 1 Faraday. How many Faraday? 1 Faraday. So the answer will be D. Is that clear, everyone?
Yes, sir.
Another very easy question on this. Okay, the next topic, I'm just going to tell you that you can easily cover it. That is your batteries are of two types. We will discuss about it. Please do this question. In the next class, we are going to start thermodynamics. Any answer? No, wrong answer. Okay, I'm gonna explain it. You can see. When 0.1 mole of MnO4 minus 2 is oxidized, the quantity of electricity required, we need to calculate the charge to complete oxidize MnO4 minus, basically MnO4 minus 2 is converting into MnO4 minus. Now you need to calculate the oxidation state first. If you are going to calculate the oxidation state, this will be plus 6 and this will be plus 7. That means one electron of magnesium has been lost. So you're going to write one electron here. Now this is a balanced chemical equation. Okay. So as you can see, 1 mole of MnO4 minus gives you 1 Faraday, because 1 mole electron is equal to 1 Faraday. That's why I just directly wrote 1 mole of this will give you 1 Faraday. So 0.1 mole of MnO4 minus 2 will give you 0.1 Faraday. And you know 0.1 Faraday, that means 96,500 Coulomb. And hence you can easily solve this 0.01, or what it is given 0.1, right? So you 1 by 10 into 96,500, and hence you can easily cancel it. You will get 9,650 Coulomb. So this will be your answer. That is C. That is your C. Is that clear, everyone?
Yes, sir.
So this topic is quite important for you. The next question I'm going to give you is this. Please do write it if you want to write the above solution, and then do question number 22. Please do attempt the last question. Should I explain?
1 minute, sir.
Steph, are you done with this? Okay, I'm gonna explain. See, it's very easy. How many grams of cobalt metal? No, it's wrong answer. We need to calculate the mass deposition of cobalt, and it is given that cobalt 2, that means cobalt is in plus 2, that gains 2 electron to give you cobalt solid, right? Now you just need to do this ZIT. Z is not directly given, so you are going to apply E by F. It is similar to the same like copper, the first question. E is not directly given, so molar mass upon N, F into I into T. N can easily be calculated because cobalt in parenthesis 2, that means it is in plus 2 oxidation state. Molar mass, that is also given, I think 59. N is 2. Faraday's constant, you know that 96,500. I, that is 10 ampere, and time that is 109 minutes. So you need to convert into second. And after that, if you are going to solve it, you will be getting the answer 20 gram. So here the answer will be your C. Is that clear, everyone? Saf, where have you mistaken?
Sir, I took only 1 electron for N5.